Okay, so in this short video, I'm going to calculate the standard deviation from this data set, which is has a lot of repeated values. Okay, so this is taken from the book we're using. For disclosure, I think it's probably the images from the book, but it's just a simple values of an example of homes and how many children live in each home. As you can expect, you're going to have a lot of repeated values, right? So you're going to have a lot of zeros, ones, two, threes. So if I did a standard deviation from these, it would be kind of silly to have a table of 50 values down, and then find the mean, and then go across and do that. So why don't we first do a frequency table, not a distribution, because I'm not going to do any classes. I'm going to just find how many homes have 0 children, how many homes have 1, how many have 2, and so on. So if I make a table, before you see the third column here, these are the values, how many children, how many homes have 0 children. 10 homes have 10 children. So I'm not going to do it carefully, but so there was 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh yeah, I found them all. Right, so 10 of them have 0 children. How many of them have 1 children? Well, 1, 2, 3, 4, 5, 6, 7, 8. You get the idea. I'm not going to do them. If I found them all and I counted them carefully, I probably should have gotten 19 of them. Okay, so to find the mean, you would add 10 zeros, which doesn't contribute anything to the sum, so that's right here. But you would add 19 ones, so just multiplying 1 times 19 gives you that. How many homes had 2 children? 7 of them. So that means that to find how many, when you added 2 plus 2 plus 2 7 times, the sure way to do that is to multiply, right? So in terms, that's what this operation says. You multiply in x, the number of children, or the data values, times the frequency. So you multiply these 2 columns to get these numbers, right? So it's a very simple math operation, and then you add these values. The sum of the x's is 91. Adding the frequencies gives you the total number of data, so I get 50 data points. That's how I had. So then something important to remember here, to get the mean, I need to divide my sum by the number of data, right? A common mistake is that sometimes we forget that we were dealing with a frequency table, and we say, well, I have 1, 2, 3, 4, 5, 6, 7 entries, so I divide that number by 7. Which would make no sense. If you think about it, the number would give you more than 10, and it cannot be that the mean is more than 10, right? The data you had were children at homes, and you saw a lot of zeros. So don't forget that you have to divide by the number of data you have. This is a shortcut to do it with 7 rows, but you have 50 data points. So you have to divide by 50, okay? So you divide 91 by 50, it gives you 1.8. So that's my mean, okay? Now I'm going to follow the same idea to find the standard deviation. You're going to subtract each value from 1.8, xi minus the x hat in this case. It's a sample. I'm going to do xi minus x hat. You're going to square it. But I have to do, for example, for all the zeros, I would have to do 0 minus 1.8. I get a negative 1.8, a negative 1.8, a negative 1.8 10 times, right? I have 10 zeros. So instead of doing that, I'm going to follow the same idea in the table, right? So I'm going to do 0 minus 1.8 is negative 1.8. You square it. But then you have to add 10 values, right? This will contribute 10 times to the sum, so you multiply by the frequency. So if I put a label up here, it would be something like this. Like this is x minus x hat. This column is giving me x minus x hat squared. Okay? And here you're multiplying that by the frequencies. So x minus x hat squared times f. Right? So this is what this column is doing, and you multiply it by the frequencies because that's like a short way of adding this number 10 times, adding this number 19 times, right? And so you have it all condensed in this table. So again, this would be very easy to implement and better to implement in a spreadsheet, doing the operations by columns. Then you add these values to get the sum. I still need to divide. Again, this was a sample, so I'm dividing by 49, not by 50. Take the square root to get the standard deviation, and it's approximately 1.7. So this is from group data because I had a lot of repeated values. Okay, it's going to be different if you had a frequency distribution where you have an interval of how many data lived in that class. So that's going to happen as well. And I'll do an example. The next video would be doing in a spreadsheet. I'm going to do, sometimes we don't have access to the data itself anymore. You just have the frequency distribution, and you want to approximate the standard deviation from that distribution. So we'll do that in a spreadsheet in the next video.